This video will probably give you a better understanding of binary counting. We can program Kara to count in binary by making her go through a 2D world and dropping clovers where there are 1s and leaving square blanks where there are 0s. Kara should start at the top leftmost square and go down to the bottom rightmost square, so that each row represents a binary number and Kara counts up by 1 as she goes down a row. The problem is that Kara wouldn't be able to tell what number she is at based on the row she is standing on. Given the sensor she can use, Kara only sees the square she is standing on and neighboring squares. So to find a solution, we need to find a pattern in binary counting that is programmable with Kara. First, understand that as you count up by 1, there are 3 possible events that can happen within a digit. The digit stays the same, a digit changes from 0 to 1, or a digit changes from 1 to 0. For the rightmost digit, however, it is constantly changing as the binary number keeps counting up. So the rightmost digit is never the same. So, if the rightmost digit changes from 0 to 1, then all other digits on the left stay the same. If the rightmost digit changes from 1 to 0, then the digit on its left cannot stay the same. It must be changing either 1 to 0 or 0 to 1. If the next digit changes from 0 to 1, then all digits to its left will stay the same. If the next digit changes from 1 to 0, however, then the digit to the immediate left of this must not stay the same. This pattern continues, following the digits from right to left until we reach a digit that turns from 0 to 1. Then, every subsequent digit to the left is just the same as the corresponding digits of the previous number. To make this seem less complicated and convoluted, imagine the pattern as 2 states, a +1 state and copy. Think of the +1 state as the events for when a digit changes, and the copy state is the event for the digits staying the same. First, start by always calling the +1 state on the rightmost digit. If that digit changes from 0 to 1, then call the copy state to all other digits to the left. If the rightmost digit changes from 1 to 0, then you must recursively call the +1 state again, this time on the next digit to the left. Keep calling the +1 state until one digit changes from 0 to 1. After that, use the copy state on the rest of the digits to the left. Now that you understand the pattern, can you apply it to Kara?